the force between 15 and what 21, 1 and 3. So I'm saying that for resultant force is simply the sum of what each force is here. That is the first one that we're considering with this one. That same first one we're considering with what? With the last one. So I'm saying that F1 resultant is equal to what there? F12 plus F13. As easy as this, please. Now my next task now is that I will actually find the value for F12 and F13. So I will look for the value of what? F12, F13. If I get the value there, I'll put the value here and I'll get the exact value of F resultant, or the resultant force on charge Q1. Now let's get F12. So I'm saying this, please. F12, let's get F12, F12. What do we know? F12 can be expressed as K, can be expressed as K, Q1, Q2, of course, 1, 2, Q1, Q2, all over R12 magnitude all squared dot unit vector of R12. So I'm putting this man in terms of vectorial form, right? This here is expressed in vectorial form. Now proceed for me, please. From this point here, now here's the concept. Your first task to get is to get your R12. That's your first to do, please. When it comes to the concept behind Coulomb's law in terms of vectorial form, your first solution, your first breakdown should be what there? R12. So I'm saying this, please. Let's get R12. So R12 is equal to, the formula is easy as, I have R, please pick out R and 1 and then pick out R and 2. So R12 is simply the difference between R1 and R2. So I'm saying this, please. The formula becomes R1 minus R2. That's the formula to calculate the position vector of R12. This is now equal to, now please, when it comes to R, we know that R is simply what there? The distance apart. That's all. So if R is distance apart, now listen please. We know that this one is position 1, 2, and 3. This man is Q1. It being Q1 means this position is what? At section 1, section 2, and 3. Now listen please. I'm asked to find R1. Where is R1? R1 is distance at section 1. Section 1 is here. There is no distance here. This is section 1. This is starting point.